Okay, the problem is find the maximum number of the elements in the subset. So what is we are given as a positive integer nums and integer array nums. So we need to select a subset of numbers which satisfy the following condition. So we have to select this as a subset of condition like we can see it is a subset, not a subarray. Subset means we can choose any element in any order or something. Or subset of another subset of nums. We have to simply have to pick up from the entire list of the array and then numbers in the array. We have to pick up some numbers and make a new array. That's all you have to do. So what is the condition? You can place the selective items in a zero index array such that follows the pattern. So we can pick any number x. Pattern should be x square, x to the power 4 up to it is, see, it is transferring in 2 square. So k by 2, then k, then again k by 2 and disorder. So that means simply if I give an example, you can take this like 2. If I start x equals to 2, then x to s square is 4, x to the power 4 is what? 4 square, 16, then 16 square, 256. Then you have to reduce again like 16, 4, 2. This is how you should do. Okay. So it should be any order, like it could be 2 4 16 4 2 this, but it cannot be possible like this 2 4 16 2. This is not possible. So there should be symmetrical. This it is symmetrical. Okay, so this is symmetrical and this is symmetrical, and but the middle item always should be singular item. Middle one that cannot be symmetrical. Middle is always symmetrical. So notice here k and both sides is k by 2 k by 2. Last element is x, last element is x, then next element is x square, next element is x square. So it is actually a symmetrical array. Last element, first element will be the same, and the middle element will be the kind of singular item only. And it should be that what is the difference between the consecutive item. So it will is a monitoring increasingly array. So it will be difference is square after it reaches the peak. Whenever it reaches the peak, it will the square root of the previous item, square root of the previous, something like that. It will move. Okay, so see the example here. They are also given. Example is like as I given you 2 4 16 4 2 or 3 9 3. See 3 square 9, then this is decreasing 3 9 3. The pattern is not like this 2 4 8 2. It is not a pattern. See here why it is not a pattern. 2 is there, 2 square is 4, but it will be 2 to the power 4, 2 to the power 4 to 16. So even if like you can say like element of x square. Okay, so but the thing is, don't think of this put an element and doing the square. Don't think like increasing square or 2 to the power 4 to the power 2 to the power 4 or 2 to the x to the 4 x to the power 8, sorry, x to the 4, then x to the power 16 like that, or 8 like that. Don't think like that. Think this is like one item, then it's square, the next item, then it's square. After that it reach at the peak, then it is the square root of that. Think this way. Don't think it is dependent on x. Just say like first element is the square of the previous one until it reaches the peak. After that, next element is the square root of the previous element, like that. So return the maximum number of elements. So we don't have to return the subset. The nice thing is you don't have to return the subset. You have to return the maximum number of element present in the sample. Like from the given nums array, what is the maximum length subset we can prepare using this condition. Okay, so what is the constant? Length of the constant is 10 to the power 5 and length of a number is 10 to the power 9. So this is 10 to the power 9. So let's see how could we solve this problem. Have I started the recording? Yeah. So what we will do here, let's take some example. This is the example. So for this array, what could be the our, let's make some, try to make some uh, subset. Okay, let's take another item, that is 8 and then 16 and 16. Okay, let's make some so what could I do if I start from that 2, and then I can make things. What 2 here, I need how many 2's are there? 2 2's are there. Okay, so how many 2's are there? Only single 2's are there, so no need of that. So then what can I take? I can take 9. So 9, after that what I need? 9 square I need. 9 square is not present in my case. So also I need 2 9s, so it is not present. So nothing is there. And next, what again, 7 is also 7 square is not present. So everyone contribute one. So think of it has some repeated numbers there, right? So if it has only, but if had only the unique numbers are there, then one like 2 3 then 2 3, then 5 7, like that. If single numbers are there, what will be the answer? Answer will be 1. Answer will be 1, because I can pick individual number, and this is also a valid number, because see, x, that is the symmetric as well, like single number is also symmetric. So it is also only one item is there, only x is there. uh, that's why it is also, it's possible. Okay, so it would answer will be either 2 or 3 or 5 or 7. These are the answers are possible. Okay, so answer will be the one, because a single item is always symmetric and is also following the condition. Why it is following the condition? There are not there is no two items are there. So our pattern is x square, x to the power 4, I guess, x to the power 4, then x to the power 8, like that only, right? So is it so after that it will goes on, and then x to the power k by 2 or something. So and then x to the power k, and then reverse, then opposite order, same thing in the opposite order, fine. But if only x is present, so nothing is, it is also matching the pattern. Now only x is present, so it is obviously, it could be x, it could be x to the power k only. So x is there, so it can be written as x to the power k. Considered x to the power k or simple x, it will be follows in the pattern. So if all unique items are there, then it will be 1. Fine then. Okay, let's see the example. Let's continue the example. So example what we're taking, like, okay, 7 is only answer equals to 1, answer equals to 1. So by default answer is 1, because see, nums array have the at least one element, and that single element could be itself one subset of that nums, and it could be 1. Okay, after that, let's take our look about 3. 3, do I have 2 3s are there? Yes, 2 3s are there. 3 is there, this, and this 3 is there here. So 2 3s are there. So what is the next thing in the, it should be element is square 9. So 9, it could have 1, it could have 2. If it has 2, then we can look for the in the what should I say, it's square. So if it is 2, its square is present. Yes, it's present is 9, 9 is present. What is the occurrences of the 9? How many times 9 has appeared in the array? One time. So I'll put 1. What is the length of this? Lengths become 3. Lengths become 3. Okay, then think of about 4. 4 is there, I can take 2 4s are there. Yes, 2 4s are there, I can take 2 4s. Okay, then what is the next item? Next item of 2 4, this 2 item is 16. 4 square is 16. So how many 16s are there? 2 16s are there, then I will take 2 16s. Okay, but after taking 2 16s, are there 16 square is also present? No, 16 square is 64. 256. 256 is 256 present? No, 256 is not present, right? 256 is not present. So right now, what is my current array? Current array is this one. Current one is this one. But can it be it is satisfying my condition? No, it is not satisfying our condition, because it should be symmetrical, but it should be the odd number of length. That means middle item must be present at most 1. Okay, not at most 1, exactly 1 actually. So if I do that, so what I could do, instead of taking 216, I can write this way. I can write 4 16 and 4, I can write this way. Instead of choosing 216, I can choose only 116. Then it's also a valid condition. So it will be again 3, length of 3. Okay, for 8 I can choose 8, but 8 square 64 not present. Then again 4 3 I have already checked. Then 16 I am getting. So 16, what is the square is 2256. It is also not present. So answer becomes 3 for this case. Okay, fine. Let's take another example. For same example, let's take it, and I will take it as a 2. Well, instead of 16, I will take 2. That means it is there, and same example I will take, and I will add extra 2 here. Okay, so here what are the cases we are getting? We are getting 3 9 3 3 9 3. Another array what we are getting, subset of this array is 4 16 4. Okay, so if there are 2 are there, so see, right now same thing is there, nothing will change. So I know that in the previous case I got 3 9 3 In another case we got 4, 16, 4. Okay, so what happened if we do extra 2, it will add, like, see, when we're getting 2, we are getting the number of 2's are there, 2, I need 2 number of 2's, right? 2 number of 2's I am getting it, so I am doing 2 number of 2's. After that, what is the square of 2 is 4. Is it present twice? Yes, it is present twice. I will add 2 number of 4. Okay, so what is the number of 16? 16, 4 square is 16. How many times it is present? 2 times. So I can adding, right now I am adding 2 times of 16. I will see. So 16 and 4, 16 is there, 16 is there. Right now how many 16 is there? Now is the 16 square is present? No, 16 square is not present. So I will remove 1. I will remove 1. Okay. So that is the case. What is the length? Total length will be 5. So answer will be 5. Okay, so one thing I need one thing you notice, like I need at least one thing, that is the count of the numbers, like how many times 2 present, how many times 4 present, how many times, like this occurrence of the number I need actually. So obviously I have to, one thing is come to my mind, so I have to store the frequency. Okay, fine, I have to store the frequency, and for that I have to need a hash map or something I have to need to store the frequency. Obviously storing the frequency is good for the hash map. Fine. Now the approach, let's think a different approach. What we are doing actually earlier, we are checking whether it is the item present twice or not. If it is present twice, we are going to add it, and then we are checking for square. If it is also present twice, we will adding it until it's square not present in the array. We are checking like this way. Instead of doing that once, then after that, if it has a square is not present, and like 16 present twice, like that, any item present twice and its square not present in the array, then we are removing one item from our list. So instead of doing that, we can simply do another technique. Is that, so I will check like whether current number is present twice or not. Current number is present twice or not. If it is present twice, then we will also check like whether its square is also present or not. So if both are condition is satisfied, then we will add into the our answer. See here, what actually I mean to say. Initially, my count of the array, let's say count is nothing but size. So I'll make it size. So size, initially size of the array is nothing but 0. Initially size of the array is 0. So what I have to check? I have to check each and every character present, like each and every unique number present in the array. So you will say the time complexity will exceed. Now I will talk about time complexity later. So first, what as I told you, I need what? I need the count. So 2 is present twice, and storing, just counting the digit and storing into the some map. Okay, so 2 is present twice. Then 4 is also present twice. Then 9 is present 1. 7 is present 1. Then 3 present twice. 3 present twice. 4 present, I already written 4. 4 present twice. 16 present twice. Okay, so this is my count. So I have to check for each and every digit present in the unique digit present here. Because why we are checking for unique digit? See, so as you see here, this is the same thing. This is the same condition earlier as well. Copy, move it here and paste it here. So 2 instead of 2's, it is only 1 prime is present at time. So here, why I have to check for each and every time, like each and every digit. See, if I checking from 2, and you can see 2's have present only one time, only single time 2's are present, right? So the problem is, but there is a pattern between 4, 16, 4. Here it is a pattern for 2, 4, 16, 4, 2. But here it is a pattern for 4, 16, 4. So pattern can create at any moment of time. So we have to check each and every item for this what array, for this array nums, our nums array. So what we will do, instead of we'll follow this approach, we will check whether my current item, whatever my current item, present twice or not. If it is present twice, then only we can add twice, right? Two items inside my array. And another thing you also need to adding it twice, like whether we should add twice or we should add only single item. We could do that. So we can do like check twice and as well as is square present or not. If it is square is present, then I will add that. So let's see. So I will check for 2. So 2 is present twice. 2 is present twice. From here I can say 2 is present twice. And whether is square is also present or not. 2 square is what? 4. 4 is present? Yes. I will first check 4 is present or not. If it is present, then I will simply add 2. So hypothetically I am adding. So I'll just increase the size by 2. Okay, now it's turn for 4. 4 is, that means 4 is present. Now I'll check 4 is present twice or not. If 4 present twice, then I will check is 6, like is square present twice or not. Okay, so square is present or not. Okay, so I'll check 4 is present twice, so I can add 4. But I have to check another thing, is square also present or not. 16 present or not. 16 is also present in my array, right? So square is also present, so I will add 4 here. So size become what? Size become 4, isn't it? Because I have adding 2 pairs. So 2 pairs means 4 items I have added. Now next item is 4 square. 4 square is 16. So 16 is present or not? 16 is present or not? So 16 present twice. Yes, it's present. Now I have to check if square is also present or not. If square doesn't present, that means it is, I cannot add 16 twice. Okay, then I will stop the loop. So I was checking the loop, I will stop the loop and directly include 16, because I will do plus 1 at the end, plus 1 16. Because if it is not if even though it's present twice, but its square doesn't present in the nums array, that means what? That means we cannot add 16 twice. 16 will contribute 1. Okay, and that will the case. Okay, so this is the reason. So let's talk about other cases. So I told you I have to check for each and every cases. So from starting from 2 is done. Next item, let's say it is hash map I was putting. It's unordered hash map, you can think of it. And the next item is 4. So I will do the same approach. Like 4 is like, now my answer becomes 5. Okay, maximum answer becomes 5. Now I will check for 4. 4, this is the example as you notice, but let's do the dry run. So 4 is how many times it is present? 4 present for 2 times. 4 present for 2 times. Okay, 4 present for 2 times. Yes, is square present or not? 16 is also present. If it is square present, answer starts, I start with 0. I will add 4. If current item present twice, and the square of the current item also present in my nums, then I will select, okay, I can current item present twice and is square present, doesn't matter how many times present, is at least present. If it is present, that means what? That means current item can contribute twice, otherwise it will contribute 1. Okay, so this find 4 I have done. Then 16. So 16 present twice or not? 16 present twice. Yes, 16 present twice. And whether is current is square also present, but see, 16 present twice, but square doesn't present. So that means what? 16 will contribute only once. So earlier it becomes 2 and it becomes 1. Whenever square doesn't present, I will simply increase 1. Okay. Another time 4 is a 9. I will check 9 how many times is present. 1 time is present. So if my loop will be like how many times 9 is present. 9 present only 1. It is ignoring the first condition. First condition or it should present twice or and square present. If that is the case, I will increase by 2. Otherwise, I will increase by 1. So 9 doesn't present, so I will increase by 1. So size become 3 here. So but okay, for earlier case, for this length is 3, but my answer is length of 5. So my current will be the current answer. So after for the 9, size will start with 0. Size will start with 0. So 9 will check it is present twice or not. If it is not present twice, then I will simply do by increase count by 1. Why count increasing size by 1? Because as I told you, 9 could be itself one subset, and also maintaining the what should I say? Maintaining the characteristic. So size will be 1. What is the maximum size of answer right now? It is 5. So I will not update. The size will 0. Then 7 also can contribute as a single one. So 7 is also 1. For 3, let's say setting for 3 present twice or not? Yes, 3 present twice. 3 square present, 3 square present. Yes, 6 square present. Okay, so 3 square present and 3 is also present. So 3 is also present twice. That means what? 3 square present and 3 present twice, that means 3 can contribute twice, because I know my square is also present, he will also contribute, it will also contribute. But even if it is contribute, so whenever a time for checking is square contribution, we will check the separate case. But right now I am present, I am present twice and my square also present, that means I can contribute twice, so size becomes 2. Now for checking for its square size is 9. So 9 present how many times? 9 present 1 or 2 times. It's present only one time, single time, right? If it is present single time, it can contribute itself. So only 1 9 can contribute. 2 9s cannot contribute. So it becomes 3. But and loop will end. If any time my square doesn't present, or I am not like current whenever the current item doesn't present twice, or current if it is present twice or more than 2, and if uh, its square also present, then when it will contribute twice. Either of the cases is not satisfied, then uh, it will only contribute 1. So current is size will be 3. So what is the maximum answer right now? 5. So it will not contribute. Fine. So after that I will check 16 once. 16 can contribute itself, because 16 present twice is true, but 16 quite doesn't present. That means 16 will contribute only once. So that's why size will be 1 and current size is 5. So that is nothing the case. Fine. I have checked all the cases. So answer will be 5 here. See this example: 2, 2, 2, 2, 2, and 4. If this is my array, what will happen? If this is the case of array, so what is my frequency array? Frequency array is nothing but 2 is 2 present. Why it is not color got change? 2 present what? 2 present 5 times, 4 present 1 time. So what are the cases we can think? If it doesn't matter how many times it present, 2 present 100 of times, 200 of times, 1000 of times, doesn't matter. 2 can contribute only 2 items. Doesn't matter, because we cannot take 2, 2, 4, 2, 2. It is not satisfied. So one item, if it is present more than number of 2, still it will only contribute 2, like in the size. It cannot exceed that. So simply, even though its number is exceeding more than 2, it will not contribute. I need at least 2 items. At most 2 items. It could be it contribute for 0, it contribute for 1, it contribute for 2 items. So at least 2 items, like minimum is 2. It is, I will not check if it is 5 or maximum number. If it is maximum also, stay like 100 times, 1000 times, it only contribute only twice at most. Okay, so here also it is, even the thing, let's run our algorithm. So starting from 2 present twice, more than twice or not? Yes, twice or more than twice, or you can say more than 1 or not. If that is the case, more than 1, then it will, and its square is present, square 4 is also present, then it will contribution, and answer becomes size becomes earlier 0, it will contribute 2. Now 4 is present, 4 present twice or not? 4 present not twice, so it will contribute only once, so size becomes 3, and that will be my answer. Only these are there. So these are the cases. Okay. One special cases are there. One special case is there. That is nothing but 1. See, I can write 1, 1, 1, 1, 1, 1. How many times I can write? It will satisfy my current condition, but it should be a odd number. See, 1x, if x equals to 1, then it could be x square is 1, x to the 4 is 1, x to the power 8 is 1, everything is 1, everything is 1. So if it is 1, it's a special case. If it is a 1, it's a special case. How many number of times I can check? So this frequency of 1 matter, like as I told you here frequency of 5, frequency of 2 or 4 or any other digit doesn't matter, because square changes and it contribute only 1. But 1 is the special kind of number. It matters. The frequency of 1 matters. Why it matters? See, square of 1 is 1. Square then square, like 4 power 1 power 4 is also 1. If power of anything of 1 is 1, so it matters. So what actually my target? My target is create a symmetric array with that condition, and it should be odd length. Okay, so if 1 present 5 number of times, so I can make one array of this 5 1 I can take. I can create one array, and answer will be what? Answer will be 5. Simple. Because size of 1 I can take. What if 1 present 4 times? Here in this example, 1 present 5 times. Okay, 2 present 2 times, 4 present 1 times, 3 present 1 time. Okay, so if 1 present, I will check if 1 is present. I will do some cases for number gets 1. I will do some cases, and I will do 5. And other case, answer becomes 5. Answer become 5. If 1 is odd number, I will directly take this 1. Not answer. Initially answer start with 0. Initially answer start with 0. Current size of the array, I can create, if 1 present odd number of times, I can take all the ones and it will satisfy my condition, and my current size of that 1 will be that odd number of ones. Okay, so right now size becomes, if I consider only 1, current size become what? Size can be become 5. Okay, the answer update by 5. Simple. Then check about 2. 2 present twice or not? Yes, 2 present twice. 2 square present? Yes, 2 square as well present. So size initialized with 0, initialized with 0 and 0, and 2 square, 2 present twice, at least twice, and square is also present, so size becomes 2. Okay, after that I will check for 4. 4 present twice or not 4 present, only 1, so it will contribute only 1, but 2 plus 1 is becomes 3. But what is the current answer? Current answer is nothing but my 5, so it will not update. So then I will check for 3. Like I will check 3 present twice or not. Yes, 3 present twice. Sorry, 3 present once. So if it is present once, then it will contribute only 1. So size will be becomes 1. So it will not update because the answer is the 5. Like answer will be the maximum of the answer, na current answer, current position. So for 4 also it is present once, is square not present, so it will contribute as a single item. So size become 1 and it will not update. What if this 1 is missing? What if its answer is 4? If 1 present even number of times, maximum how many ones I can take and make that array? I know count will be 4, so I can take maximum 3 items. So if it is even number, I will take the one less than the frequency. Okay, if it is present 4 times, I can make at least 3 na. So because it have to be symmetrical with that specific order, specific condition, and it should be a mass pair present in the odd number of cases. So maximum how many odd numbers we can take for this even number? Obviously even number minus 1, that maximum of that odd number I can take, I can create from that even number. So that's why if 1 present odd number of time, we'll just take 1 less than that frequency. Simple. So these are the test cases. Hope you will get it. Let's write the pseudocode for this. So let's write the function. The condition is, let's say, find subset. Find subset. I don't know function name. Find subset. What is given us? Nums is given us. So nums is given us. So what I need to count the frequency. So, and I am storing in the hash map. So I am creating one hash map. Let's say frequency. Frequency is nothing but on map or hash map. But is key is also integer. Key is also integer, and is value is also integer. I am storing that individual number as a key and its corresponding count. So these are the normal cases. Fine. This is the case. So I need a for loop to initialize this as now. So for each number in present in nums. I will do that. So I will do here what? I will do simply one for loop is there. So I will update that frequency of num. Frequency of this number. So it may present, may not present. So it will be get, or by default is there, get or default something function will be there. So I will say like frequency dot get is nothing but my number. I want to get number. What is the get num? That means it is returning get of num if it is present. If it is not present, then it will return 0, last one. So this is like nothing but my you can say like this is nothing but this way. If I write this get and num function, there will be much in your code, whatever you code, the language C++, Java, Python, there will be some kind of function get or default kind of that. Get means if it is present there in the map, it will return that item corresponding value. If doesn't return that, then if default value is also provided, it will return the default value. So if I write this pseudocode for this get, it will looks like this. If not frequency dot find, if it is not find, find what, find this number, find this number, then it will return, then return. If it is not present, it cannot find, that means it is not present, return 0, otherwise it will return. So if condition is false, that means it is present, then return frequency of number. Simple, right? So this is a, like if you write the pseudocode of this dot get function is like that. So this is the pseudocode I am removing, hope you get it. This is my say. So now name could be matters, it could get or default or get or some other name will be there, please check it, or do I return you the pseudocode, you can check use the pseudocode as well. Okay, so this is my case. Cool. So I can initialize answer, and initialize answer you can start with 0 or 1, you can start, doesn't matter, because see 1 by at least you know, like it no common or no pattern is present. Each item, if all unique items are present and it is doesn't form any condition with any number with this num, it will contribute itself. So you can start initialize a number, answer is 0, or in our case it will automatically update by 1. Okay, answer equals to 0. Now I have to iterate for each number present in the, for each number present in the frequency of keys, frequency dot keys. So all unique items. So I have counted the frequency. Now let's take an example. Let's take this example. So after our this loop works, then our frequency become this one. Our frequency become like, looks like this. Okay. So our frequency look like this. So now I have to check for each item. For each item of this frequency of keys. If it is the, if each item is present, so if item in this frequency dot keys we are checking, I am initializing one count equals to what, 0, count equals to 0. Okay, so I have one special condition, as I told you, like if it is 1 I have to then my frequency matter, if it is not 1 then the frequency doesn't matter. So let's say 1 equals to, let's say here 4, let's say here 4, 1 equals to 4 here. So if count of 1, if number equals to 1, if it is 1, then I have a special condition. I will do what, I'll do, like I will assign count equals to frequency I, frequency of this number. But you are told me, like I told you na, like if I have to take odd even case like that, so here I will write, instead of write for that, okay, for as I told you, let me write that thing what I told you. If number modulo 2 equals to 1, if it is a frequency of number is 1, frequency of number is 1, then I will do what, otherwise I will do what. Okay, so else if frequency of number equals to 1, that means it is an odd number, then my count becomes frequency of number, okay, otherwise else my count become frequency of, else means it's a even number minus 1, this will be my count. So I can write this way, but instead of writing this way I can write another different way as well. See this one, I will simply initialize my count as a frequency. I'll simply initialize the count as a frequency. So frequency becomes, sorry, not frequency, I initialize the count as frequency, so count becomes that frequency. Count become the frequency of 1. I can simply initialize. Now this count could be, this frequency could be odd number, could be even number. Now I'll put a check. If so, if here, not here, not outside in this indentation, if my frequency, if my count, now if my count is a or even number, modulo 2 equals to 0. If it's a even number, that means what? I should have reduced the thing. So I will do this line, count minus equals to 1, minus equals to 1. Got it? Hope you get it. Okay, there is another way to writing this condition. I can use not count and 1. So this is the shorthand, count and 1. So whatever, whenever you do x and 1, it is a bitwise AND. So if I do bitwise AND, then it will, if it is x is a odd number, it will give us 1. X is a even number, it gives us 0. So you can write as count and 1. It's a bitwise operator. For your shorthand, I am writing this. So you can, in the, this entire condition can be written like this. Entire condition can be written like this way. So this is much faster. Whenever you use any bitwise in operation, it will much faster than normal operation. Okay. So anyway, so for now it doesn't matter. So I will do that. Else, if that is not the case, if that is the case, I will do number is 1. Otherwise, else, what I will do that. Okay. Let me just resize all the things because it will take too much spaces. So let me resize this and come back. So else means if it is not a 1, then what are the cases? Then I told you, like, I need to iterate. So another iteration I need. So while I will do a while loop. So while there is a condition, as I told you, while. So while I will check what? While my frequency of this num is greater than 1. You can say greater equals to 2. I can write greater than 1. So both are same. Okay. So frequency now is greater than 1. If that is the case. And don't make it as a count. Why I am writing this as a count? I can make that count as name as size. Because this is nothing but actually size. This is a good name actually. Naming condition it is size, not a count. So size. It becomes size. And here will be size. So if frequency, that while frequency of number is greater than 1, and what I have to check, and if both are true, and frequency dot find what I need, number into number. If both are true, like if my count is more than 1 and my frequency, like also my square of that number also present, as I told you, if square of the number also present in my frequency, that time what we could do, we can simply increase the size by 2. So size class equals to 2, and my current number becomes what? Current number becomes number equals to number into number. Then I will check again that. Okay. If not, it is not the case. If it is not the case, then at the end, if anything is false, I will simply increase size by 1. Increase size by 1 plus equals to 1. Okay. So this is what we need. After that, whenever this else statement stops, okay, still taking much place actually. Let me remove these extra brackets because one liner loop it is. Then move this part and this part and this one. So at the end of this else statement, my answer will be updated by, so this is inside the for loop actually. So this is inside of this outer for loop. So at the end, whenever each outer for loop is finished, I will simply write like size, answer will be updated by answer equals to maximum of answer current answer or current size. That's all. At the end, I will return the answer. So here the loops end, and at the end I will simply return my current answer, and also my this ends, also my function ends. So this is my function. Okay, this is my function. So what is the time complexity first of all? So time complexity, let's say length of the nums is n. So this is running for big O of n. So this is coming from big O of n. Okay, and this frequency for loop, this is a running for number of see number of frequency of keys, right? Frequency dot keys frequency dot keys. Let me write it. Frequency dot keys. So keys means it is storing only running for the unique element, right? So unique time it is running. So number of unique item present in the frequency array, it will run that time. So it depends. What is the, let's say if it is what is the maximum time it will run? So number of the unique time it will run. So the thing is, it will show the unique number. It will show the unique number present in the this for loop will run for unique number of times. Unique number of times a number present in the in our nums array. So it is nothing but length of the keys. So let's say it is running for big of d times. The unique number of digit it is present. Distinct number is present. So let's say it is big of d. I am considering d is the unique number of items. D at most d could be 1. At most d could be 1. See, and what is this case? What is this second for loop will run? So there is a condition for the second for loop. Second for loop is nothing but, see, we are every time of every unique digit we are checking which square it present or not. Okay, so this second while loop keeps squaring the current number value, it keeps squaring. See here, it keeps squaring the value until the square value is no longer present in my frequency. So it is actually dying by square and square. It is square and square. So how many times it may lie? Let's say my pattern is like this way. It will present too many times, like 2 is present, then 2 square 4 is present, then 4 square is present. So if my pattern, so how long it may run actually? How long it may run? So it may run for first time, let's say 2 present twice. Okay, 2 square present twice. Okay, then 2 square is nothing but 4 square. Now 4 square present twice. Then 4 square is nothing but 16 square. 16 square present twice. Then 16 square means 2 square. Sorry, 2 square is the 4 I mentioned. Sorry, 2 square. Then whole square is 4. Then 4 present twice. Then 16 present twice. Then 26 present twice. 256 present twice. This is how you can run, right? It's present twice and so on. It's present. So how many times it is like running? So it will. So for each distinct number, the while loop keeps squaring the current value until the squared value is no longer present, and it grows very fast because we are repeatedly squaring it. So it at most go to log of that number. Let's say current number is k. Okay, it go to log of k. So That is the case. It can go to log of log. In this case, the time complexity goes to, let's say my number is maximum. It goes to what? Maximum it goes to how many length? Like it maximum length, and it will be the. So what is our maximum length? Maximum length could be what is our time like maximum number 10 to the power 9. Na? So this magnitude, if you write this thing, it could be maximum number it may appear. So let's say 256 or something is the maximum number, so it will go to log of 256, log of 256 it will go. So this this is a very complex function. Actually it seems like a squaring. It is actually uh, time complexity is very high. It will go, let's say, exponential kind of that. It will very less amount of time. Even though number increase, it will take less number of time. Sorry, it looks like this way, like this kind of exponential it will take. Even though it will increase, it will not increase that. So it will be log of this maximum number it may reach. Maximum number may reach. So I am writing as a big O of, I will explain, big O of log of m. So maximum at the m, maximum it could be 10 to the power 9 as per the constant. So log of m. So it will be very small value. Even though it takes, it looks like checking every time. It's very small value. So now think. Now let give another example. The example means, like, let's say big. It is saying, I told you, it will run for big of d times. Big of d times. So d could be at most it could be 8, because every digit could be unique, and let's say it could be unique and its square doesn't also present. So in that time, what is the length? What is the length will be? The length will be, it will run only one time. Let's say every item present only one time. Na? So let's say 1, 2, 3, 4, 5, 6, 7, 8, like that it present. Okay. So every time it will stay here. So but this for loop will stop. This loop will never occur. Why it will not never occur? See here, every item present only one time. That means what? It is not present, it is not possible this condition. It's never satisfy this condition. Like it will not greater than 1. It every time it will be equals to 1 or less than 1. It cannot reach 2. Okay, so that time this while loop never execute. So that time this becomes big of 1, so this becomes big of n time. Fine. So if it is d number of times, let's say it's a hypothetically it is a d amount of time. Okay, if it's a d amount of time, then what will happen? If it is d amount of time, then what will happen? It will happen like, then it will know how much time it will go. It will go log of m. M is nothing but the maximum number it present at most. Maximum number it present in the array. It could be that case. So in the array or maximum number it could reach, like in that case. Or you can say m is the maximum number of this array as well. So the time complexity will be big O of first is n, then d times how many times? Log of m times maximum number present in the case. This is the time complexity. Space complexity, we are taking extra space of big O of d, because we are storing the unique item in its count, right? That is big of d. That's why I named as big of d, because in distinct item I have to store na. So as a name is big of d, and even I understand why this becomes big of d. So that's all. So this is a very good problem. It's actually a good mathematical solution, you can also think. So that's all. Hope you understand. And last few days I'm not making the videos because I was really busy in some work. So I'll try to put those videos in on these weekends. So that's all. So as always, if you find any mistake in this video, please let me know so that I can rectify. And if you find any useful information on this topic, please also let me know so that I can also learn. I forgot to I remove this one. Log off. Okay. Okay then, thank you. Bye bye.